Alright guys, welcome to another tutorial. This one's going to be covering another Unit 4 section, Gene-Based Inheritance. Okay, so I think that might be the fourth tutorial, something like that. This chapter I can understand why I gave you guys trouble. I'm going to go over it for the most part in kind of categorized detail. So there's going to be a lot I skip over in this tutorial, I have a feeling, just because genetics is kind of a wider area. I'm going to focus more on what's going to get you immediately through your mastery test and post test, and we'll explore the rest of all of Unit 4. It's all kind of related. So they introduce you on page 3 to Gregor Mendel. He's kind of the father of genetics. So he's sort of a big deal. He did pea plant work and all that jazz. You can read about his pea plants if you want. But basically, he discovered a lot of different things, and we're going to define a bunch of those things. I'm going to move over to page 5, I believe. So it talks about dominance. All right. So dominance is this idea. Dominance. There are a lot of different ways that an allele can be dominant. So remember, alleles are individual genes. So like black hair, that would be an allele. Brown hair would be an allele. Big hands versus little hands would be an allele. Maybe you have like a long thumb or a crooked thumb. That could be an allele. All sorts of things. So alleles just determine what happens, what you see, what you feel, how you are, essentially. So alleles and genes, I'm going to allele is a trait. A gene is what carries that trait. All right. So I'm going to use the word alleles pretty often. In any case, you guys already have seen heterozygous versus homozygous. Heterozygous. That's an E. It just looks really weird. And then you've got homozygous. So heterozygous just means that you have an allele that's dominant and an allele that's recessive. So like big A, little a, big B, little b, that kind of thing. Homozygous means that you have either two big letters or two little letters. All right. Big B, big B. Anyway, um, that's basic dominance. But here they're going to go over in more detail. So you'll notice they didn't really do a whole lecture on this. I'm just going to go over this real quickly as a review, just in case you haven't seen my other videos. Next, they're going to cover on page 5 codominance. All right, so this is going to be the first one. Codominance. The best example of this is blood types. All right, so codominance is kind of an interesting area in that both alleles show traits. I'm gonna write show up. But yeah. The idea is this would happen if, like with cows, so they have, black fur and white spots, or white fur and black spots. However you really want to look at it. But the idea is that it's codominance because both of the alleles show up. You have an allele for black or white, and they both happen to show up in the form of spots or blending or something like that. You'll have like, different stripes, that kind of thing. Codominance, the most popular example is going to be blood. So people have like an AB blood type. Thing is, this works the same way with any Punnett square. So like, let's say I had an AB date like a B. All right. What's going to happen is that you could end up with, here's A, here's B, and then here's just B. You could end up with AB. You could end up, so this is B, and you could end up with big B, big B. But you could easily also end up with just A or just B. Alright, so in this case we had 4 possible codominance types, and this is just blood types, alright? I don't actually know what my blood type is. It's actually really important, so if you get a chance, you should figure out what your blood type is. I learned it at one point, I think, but I was like, whatever. So the point is, you should probably learn your blood type if you can. I intend to learn that again soon. Alright, so codominance really just means that both alleles show up. I'm going to summarize all different types of dominance on one page in a little while. But I'm going to move on to page 6 now. Incomplete dominance. Okay. Incomplete dominance is a little different. Incomplete dominance. Alright. So with incomplete dominance, what you're going to have is you're going to have two alleles that essentially blend together. This works best with an explanation of colors. So alleles blend together. Alright. They're often going to use the idea of flowers. You can use hair if you like, but let's go ahead and use flowers because that's going to be the one that you see most often. So you have a red flower. Red flower. Oh my god. That's an L. There we go. Plus a white flower. And this is going to be the most common example. You end up with a red plus white equals a pink flower. Okay? So this happens every once in a while. You have certain alleles, certain traits, often has to do with color and that kind of thing, where they mix together and you end up with this weird like pseudo thing. Here, so this would be a pink flower. This is kind of like if a white cow and a black cow were to mate and somehow they got like a brown cow or something like that. I don't really know. That doesn't actually exist. That's not how brown cows work. That actually works under a different idea. But yeah, but the theory remains the same. Just you're mixing two traits and they're gonna blend together. So co-dominance means both of them are going to show up and co-dominate. They're going to cooperate and both show up. In incomplete dominance, that means neither of them has a complete hold on the situation. You're going to end up with some kind of mix. It's a blending. It's less strong. Okay. So co-dominant, you definitely see both personalities. In incomplete dominance, the personalities are going to kind of mix together, and you're not going to be able to tell them apart. They're going to mix something new. All right. There should be one more that they describe for you. Let's see. So page 7 just shows you more about codom or incomplete dominance. Sorry. Huh. No, I'm kind of surprised they didn't talk about one more. Normally they talk about complete dominance. Well, whatever. I guess this up here, this would have been complete dominance. So I already went over it. I guess they sort of went over it. It normally comes first, so I'm kind of surprised. In any case, this is complete dominance. This is when you can absolutely have um, one of your alleles show up. So A, B, 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 whatever. So this is complete dominance, the thing that you're completely used to making Punnett squares on. Codominance is where they both show up, and then incomplete dominance is where they blend together. All right. So these are the 3 kinds of dominance. Let me get all that on screen for you guys. There you go. All right. And I am currently on page 8. They're talking about degrees of dominance and all that jazz. You know, we've already talked about this. These are different degrees of dominance. So I'm going to move on. Page 9, just to give you guys an idea of how to handle these questions. Jenny has a black cat and a tan cat. If she breeds the cats and produces a tabby cat, what pattern of inheritance would explain the color of the cat's fur? So luckily they have a picture of a cat down here. So if you take a look at the cat, it has some stripes and that kind of thing. It looks kind of tiger-esque. Um, yeah, it looks kind of tiger-esque, so it has multiple, traits showing up. It's not just brown, it's not just orange, it's not just black or white or whatever color this cat's supposed to be. It ends up having, it's black and tan cat. You'll notice that it has black stripe and tan stripe. So this is a codominance because you can see both of them specifically. If that black and tan cat breeded and they ended up with a child that was, gray, you could assume that that was probably incomplete dominance um, for the most part because they blended together. Okay, that was page 9. Let's go ahead and move on to page 10. Now, in real life, uh, yes. So in real life, you end up with things that are actually defined by multiple alleles. So on page 10, they talk about multiple alleles. The most important part is probably that second to last paragraph. It says that in reality, most genes have more than 2 alleles. This is absolutely true. Like everything that I've shown you, this blood type thing, A, B, you either are A or B or you're some combination of the two, right? Works the same way with all these examples I kept giving you. All the examples that we work with are generally very simple, but in real life, a lot of your traits are affected by a lot of different things. So this is just the multiple allele theory. All right, it really just says that when you're doing any kind of genetic questioning, multiple alleles can be responsible for a single trait. All right, so let me see, what would be an example of this? It's kind of like I've used hair, so I don't really want to confuse you guys. It really works best with hair. So let's talk about multiple alleles in hair. Hair, I've given you these examples where incomplete dominance, maybe the colors blend together, but the thing is, like brown hair and black hair and no, that doesn't really. Okay, brown hair and blonde hair does not necessarily mix into like a light brown hair. It's not how it works. It doesn't necessarily become a dirty blonde. There are a lot of different alleles affecting that. So you can't just assume that brown plus blonde equals like light brown. It doesn't always work that way. It can, but it does not necessarily. So the questions you're going to get are normally like, um, you know, you have this many different hair types: black, brown, gray, purple, blue, whatever. People can be born with all these things. So what do you think is responsible for this? That answer will be multiple alleles. It's just because a lot of different things affect it. So you just end up with this weird spectrum of different colors and different types. Okay? So that is how you'll handle that if you run into it on a mastery test. Let me go ahead and move on to page 11. And all right, they talk about the blood type thing, so this explains how the blood type works. All right, So you can take a look at blood type and whatnot. It explains all of this in a little bit more detail, but the point is, when you mix two things, you can end up with pretty much any of them. It's just some of them end up with different versions. There's also an O blood type, so like I didn't include O blood type because A, B, and B will never equal O, but there is an O blood type that's completely separate. But you can think of that as like the super, super rare type. Alright, so on page 12, they're going to cover something called pleiotropy. Let me start a new page. Hopefully you guys got those last notes. Feel free to rewind and check it out again. So pleiotropy. Now this is the idea that one gene affects a lot of different things. Affects a lot of stuff. A lot of stuff. Okay, so the idea here is this. I have a gene that controls hair color. So I have gene A. Okay, gene A controls hair color. Hair color. It also controls height. And then I don't know. It's gonna control whether or not I have Parkinson's. Kind of awful, but that's what we're gonna use right now because that is what came to mind. So gene A is responsible for all three of these things, and many genes are pleiotropic in that they affect a lot of different things. So these kinds of questions will show up on your end of course exams, on your post tests, on your master tests, on your end of semester, whatever else. They'll probably show up and they'll ask you something like, Billy is short and he has, I don't know, strange canine teeth, and he also suffers from, Parkinson's, and I don't know, he has purple eyes or something like that. It'll just say that like all these different things because of one gene. So he has this, so it affects a bunch of other things. All right. So the difference between pleiotropy and multiple alleles is that in pleiotropy, one gene is going to affect a lot of different things. In multiple alleles, a lot of different genes will affect one thing. Okay, they're exact opposites. So actually, let me include this on this page. So this is multiple alleles. Is a lot of genes affect one trait. Alright, so this is the exact opposite. So if you memorize one, you already have the other one memorized. Alright, so multiple alleles. My handwriting is especially sloppy today, and I'm not sure why, so I apologize for that, guys. I'm going to try and clean it up a bit. I don't really know why I'm being sloppy about it. So one big example of pleiotropy here, I'm sorry, I said Parkinson's, but let's use this one. On page 13, it talks about sickle cell anemia. Sickle cell is a big example of pleiotropy. Basically what happens is that if you have sickle cell anemia, you now have a bunch of blood issues, like a mad amount of blood issues. And you're going to end up seeing physical effects, all sorts of things. So sickle cell anemia is the prime example of pleiotropy. Anytime you see sickle cell, you can assume that they're probably talking about pleiotropy. It really just means that there's one gene that gives you sickle cell, and because of that one gene, it affects a bunch of different things, including hair color, your blood, etc., etc., etc. All right, so that's pleiotropy. Go ahead and move on. Let's see, page 15. Epistasis. Okay, epistasis. So they say that this is the exact opposite of pleiotropy, but I just told you multiple alleles is the opposite because this is one gene affects a lot of stuff. This is a lot of genes affect one thing. I'm going to. How do I separate epistasis versus multiple alleles? So they are very similar things. I'm trying to see if there's something in your. Okay. All right, cool. So epistasis, and I'm going to use this really common example as the idea, but epistasis is one gene affects another gene. One gene affects another. Okay? So this is just related genes. They're somehow related. And the most common example is albinism. Wow, that was really soft. I told you guys I was gonna write neater, and I just albinism. There we go. All right, cool. So albinism is the lack of color. So you guys have probably heard of this. You end up with a lack of pigment, normally in the pale white area. Okay, so epistasis and albinism go hand in hand in that this. You can have brown hair. Oh, that was a bad. Okay, or you could have red hair, right? Brown versus red hair. But there's also a gene that's responsible for albinism. So if this gene is active, it doesn't matter whether or not you're brown brown or red red or brown red or whatever the heck it is. If your gene for albinism is activated, you have virtually colorless hair. You have white or gray whitish hair, something like that. All right, so albinism affects this other allele. So you can have a hair color. So like there are a lot of people that are albino that are technically genetically brown and brown, but because of this thing, it affects the other. So it's not like your tutorial says it's the opposite of pleiotropy. I don't agree really. I think pleiotropy and multiple alleles are exact opposites, and epistasis is where one gene is just affecting the others, ignoring what's happening with them. All right, hopefully that'll make sense. Most of the time, this comes up with albinism and that sort of thing, so that should be able to help you get through um, that question. Let's see. So I'm gonna hit page 16 now. Okay, and then they talk about this very, very unusual blood group, which is called the Bombay phenotype. So in humans, I'm sorry, not often, but we very, very rarely end up with this Bombay phenotype. And it's an ABO blood group. It's very unusual. In that it works like the O blood group, but it lacks an antigen that the O group has, so it's a little bit less useful than the O group. It's a very unusual blood type. I don't know why you'd need to learn it. I don't think it's on your mastery test. I looked over it a while back. I really don't think it's on there, so don't worry too much about that Bombay blood type. For our sakes, I think we're gonna go with epistasis and match with albinism. So just remember that you can't have brown, you can't have red hair, whichever one, brown, brown, red, red, brown, red, whatever. And then you have another gene that decides whether or not that even matters at all. Okay? It's kind of like you could have a gene for tall or short, but then you have the gene for, you know, dwarfism, and if you have that gene, it doesn't matter whether or not you're supposed to be called tall, you end up with short or something like that. So there are often situations where one gene will affect another decided phenotype or allele set. Okay. Now they're gonna go over polygenetic inheritance. This is really simple. Let's see. So polygenetic inheritance is the same as saying. Actually, wait a minute. So I've always called polygenetic inheritance the same as multiple alleles. I'm gonna look this up now and see if there is a difference. Mm-hmm. Oh, sorry. Okay, so I apologize for the quiet pause in this video. I just wanted to see if there was a specific difference between the two, and there is. So a polygenetic trait. Let me add that on here. Polygenetic trait. All right. So polygenetic traits are going to be any inheritable trait that is controlled by multiple genes. All right. Controlled by many genes. All right. And they don't follow Mendelian inheritance. Follow Mendel's genetics. Okay. So basically, all that stuff you learn with Punnett squares, multiple alleles follows Punnett squares. So if you have uh, let's see, you have a gene that affects your hair, right? So your hair is black, but it could also be blonde, but it could also be red. And let's say you have red and blonde. So you end up with this weird strawberry blonde thing. It follows Mendelian genetics in that you can still do that whole Punnett square A B B B A whatever else, right? So multiple alleles absolutely follows Mendelian genetics. Polygenetic, on the other hand, does not. Basically, I could have blonde, black, and then suddenly something weird happens that I would never have expected, and I end up with some weird thing. Polygenetic is the same thing as multiple alleles, but it does not follow Mendelian genetics. Best example of this is eye color. Okay, so your eyes are determined by a bunch of different genes, not all of which are directly related to eye color, but they do affect it in their own ways. All right, so let's see. Page 18. Oh, they talk about how human skin's absolutely true. So like all of us are different colors. Like there are no, well, I'm sorry. When you look at people, generally their arms are not going to be the same color. Like I'm tanned a little bit, but there are people way more tan, way less tan, this and that. So skin is just completely polygenetic rather, in that everything affects it. So many different things affect skin color. So in multiple alleles, you'll end up with a lot of different traits. So, like I said, you could end up with, curly blonde hair. So, curly and blonde both affect hair, but we can mix them together in this Punnett square kind of thing. And we can say, like, okay, well, there's a 1 in 16 chance that you're going to be curly and blonde or something like that. But we cannot do that with polygenetic because polygenetic is really just we're going to mix them together and something's going to happen. All right. Let me look. 19 has a wonderful little exercise to be able to keep them apart. That might actually be really useful. So they went over all of these again. So it looks like we're hitting a summary. So that's actually it for this chapter. It is going to be a little bit harder. I highly recommend the exercise on page 19 and page 20 just to get a better idea of things in case I missed anything. Let me go ahead and get this whole thing off screen. Yes. But yeah, if you have any questions, feel free to let me know, and I will do my best to answer them. This is a harder chapter. It goes so much more in detail than what I just went over, but I'm kind of hoping that you guys will just be able to get through the test this way. All right, so do your best to try and understand whether or not things are, dominant, codominant, incomplete versus multiple alleles, epistasis, polygenetic. If you know all the definitions, you really think about it, you should be able to handle it, but it's not an easy test by any means. All right. Good luck, guys, and I'll talk to you guys later. See you guys next video. Bye.